Hey YouTube family, Namaste. I hope all of you are very fine. This is Shubhradev Nath and I welcome all of you to my channel Bengal Bro Tutorial. Welcome to the first video lecture of class 12 physics syllabus. In this session, we are starting the chapter Electric Charges and Fields. See students, I will try my best to teach each and every concept in detail from the very basic level to the next. Also, there is another good news. You can avail the lecture notes from the link given in the description box. So, all you have to do is watch this video lecture till the end, try to understand each and every concept and prepare for your exams well. That's all. Also, if you feel that there is something which you are not able to understand, feel free to use the comment section. Your bro will always be there for you. Alright? So without any further delay, let's start today's class with a brief discussion on the composition of matter. So, composition of matter. In grade 9, we all have studied that anything that has mass and occupies space is called matter. Also, matter is made up of a large number of tiny particles which are called as atoms. The atoms are further made up of subatomic particles called the electrons, protons and neutrons. Up to this much you all know, right? So let me note it down. Matter is made up of tiny particles called atoms. Atoms are made up of subatomic particles called electrons, protons and neutrons. Now see, the electrons are called as the fundamental particles or the elementary particles. Fundamental particle and elementary particle are the same things only. Fundamental particles means those particles that cannot be broken or split further into smaller particles or constituents. Since electrons cannot be further subdivided into smaller constituents, that's why the electrons are called as the fundamental or the elementary particles. So, we can write that electrons are fundamental or elementary particles. But the protons and neutrons, they are not considered as elementary particles or fundamental particles because they can be further subdivided into smaller constituents which are called as quarks. Many of you might be hearing this for the first time, so I am repeating it once again. The protons and neutrons can be further subdivided into smaller particles called quarks. That's why they are not considered as fundamental particles. But quarks cannot be further divided. That's why they are fundamental particles. So, protons and neutrons are not fundamental particles because they can be subdivided into smaller particles called quarks. Thus, the electrons and quarks together form the elementary particles of matter, which means they are the smallest particles of matter that cannot be divided further. Thus, the electrons and quarks form the fundamental particles of matter. Now that you have the basic idea regarding the fundamental particles of matter or the elementary particles, we can go for the concept of electric charge or simply just charge. Okay, electric charge is the first term in the name of the syllabus. So I'm rubbing this. Charge. But even before I discuss the concept of charge, let me give you an analogy so that you can understand it very quickly. Can you recall the names of four fundamental forces that you have learned in the first chapter of class 11? How many of you have already skipped the chapter only? Okay, so the four fundamental forces are gravitational force, electromagnetic force, strong nuclear force, and the weak nuclear force. Now, what is gravitational force? It is the force of attraction that a body can apply as well as experience due to the presence of a property called mass. Okay. So, every body has a property called mass that is associated with it. And that is why any body is able to exert an attractive force on each and all other bodies present in the universe, as well as it can experience an attractive force due to all other bodies present in the universe, which is called as the gravitational force. So did you understand? Because of the presence of a property called mass in matter, mass is able to, any body or any matter is able to exert as well as experience an attractive force, which is called as the gravitational force. Similarly, charge is also a property associated with the elementary particles of matter. So charge is a property associated with the elementary particles of matter, due to which it can experience, due to which it can apply and experience electromagnetic force. So just like a property called mass, due to the presence of a property called mass, matter is able to experience and apply gravitational force. Similarly, due to the presence of another property which is called as charge, mass, any body is able to apply as well as experience another kind of force which is known as electromagnetic force. But unlike gravitational force, electromagnetic force may be attractive or repulsive in nature. Okay, did you understand what is the meaning of charge? Charge is nothing but a property that is associated with the elementary particles of matter, due to which matter can experience and apply electromagnetic force on each other. Okay, now the SI unit of charge is coulomb. It is denoted by capital C. There are two CGS units of charge. One is the electrostatic unit, or which is also known as stat coulomb, and the other is known as, so electrostatic unit in short form can be written as E.S.U, and the other one is known as electromagnetic unit of charge, or amp coulomb. Okay, in short it can be written as E.M.U, electromagnetic unit. Now their relation with the SI unit is given by 1 coulomb is equal to 3 into 10 to the power 9 stat coulomb, and 1 coulomb is equal to 1 by 10 amp coulomb. There are some other practical units as well, some practical units. Okay, practical units. These are Faraday and Franklin. Faraday is the largest unit of charge and Franklin is the smallest unit of charge. Just let me repeat once again. SI unit of charge is coulomb. There are two CGS units of charge. One is the electrostatic unit or stat coulomb and the other one is electromagnetic unit or app coulomb. 1 coulomb is equal to 3 into 10 to the power 9 stat coulomb and 1 coulomb is equal to 1 by 10 app coulomb. There are two other practical units. One is the Faraday and the other is the Franklin. Faraday is the largest unit of charge and Franklin is the smallest unit of charge. Understood? Okay. Now we will try to understand the meaning of electricity. What do we mean by electricity? Okay, so electricity. In grade 9 only we studied that ability of a body to do some work is called energy, and this energy can be stored within a body in various forms such as light energy, sound energy, then solar energy, right, nuclear energy, chemical energy. These are the various forms of energy. Okay, similarly electricity is also a form of energy that is associated with the charges at rest or in motion. So we can write that electricity is a form of energy associated with the accumulation or flow of charge. Which means that whenever charges get accumulated in a body or whenever charges flow through a body, the energy that is associated with the charges that have been accumulated within the body or the charge that is flowing is called the electricity. Understood? There are two types of electricity. Number one is known as static electricity and the second type is known as current electricity. Okay, static electricity means it is the energy associated with charges at rest. Means whenever charges accumulate in a body, they remain in rest, and the energy associated with the charges at rest is called as static electricity. And whenever charges flow through a body, the energy associated with the moving charge is known as current electricity. You understood the meaning of electricity? Okay. So now, whenever charges get accumulated in a body, the body can apply force on other bodies. Also, it can create a region around itself where it can exert its influence, which is known as electric field. Okay. Also, it can do some work on other body, which is stored as the potential of that body. Okay. And a separate branch of physics has been devoted to the study of force, field, and the potential which arise due to the charges at rest. And that branch of physics is known as electrostatics. Okay. So, electrostatics is the branch of physics that deals with the forces, fields, and potentials arising due to static charges, or in other words, due to charges at rest. Okay, so you understood the meaning of electrostatics. In fact, the first two chapters in your physics book is a part of electrostatics only, and the third chapter is nothing but all about current electricity. Okay, now we will look into the history of discovery of charge, how the concept of charge was discovered. Okay, so historical view. It was around 600 BC that Thales of Miletus from Greece, who first discovered the fact that when amber is rubbed with wool, it can attract light objects like feather, leaves, etc. So in 600 BC, Thales of Miletus from Greece, he discovered the fact that whenever you rub amber with wool, okay, the amber can attract small, light pieces of feather and leaves, okay, which is almost similar to the magic tricks that you have performed in your childhood. Do you remember those magic tricks that you used to take a scale or a plastic pen and then rub it on dry hair, and then when you bring that pen or the scale near tiny bits of paper, you will see that those bits of paper eventually get attracted to the scale or the pen. Now this concept was first discovered by Thales of Miletus. Now why does this actually happen? It is because when two objects are rubbed together, they acquire the property which is called as charge, and that is why they can attract other materials as well. So understood why they can attract each other, or why when the two bodies are rubbed they acquire the ability to attract, because the bodies acquire charge. Okay, now we will see the different types of charge. Okay, so types of charge. types of charge. For that, we have to perform an experiment. We will need two pith balls, or you can use polystyrene balls that we can get from the market itself. Okay. So you have to suspend the two pith balls from a rigid support with a nylon or silk thread. Okay. So this is the nylon or silk thread, and these are the two pith balls. Then what you have to do is take a glass rod and a silk cloth. So I am using a glass rod and silk cloth. Rub the glass rod in the silk cloth. Okay, rub it with the silk cloth, and then touch the rod with both the pith balls one by one. Now when you rub the glass rod with the silk cloth, the glass rod acquires a charge, and then when you touch this glass rod with both the pith balls, the charges get transferred to these balls. Now the two balls have become charged. Okay, then once you touch the glass rod with both these pith balls, you will see that the two balls repel each other, means they will move away from each other. This is the first part of the experiment. In the second part of the experiment, we will repeat the same procedure but with two other different pair of objects. They are plastic rod and fur. Again, you will rub the plastic rod with fur and then bring them in contact with both these pith balls. Okay, so when you rub the plastic rod with fur, the plastic rod acquires the property called charge. Now when you touch this plastic rod with the pith balls, what happens? Now the charges get transferred to these balls. Okay, since you are using the same plastic rod to charge both these two pith balls, okay, so they acquire similar charge, and you will see that they repel each other or they move away from each other. Okay, so from these two procedures or from these two steps, what we can conclude? From these two steps we can conclude that like charges, they repel each other. Since we were using the same rod to charge both these pith balls, that means they acquired similar charge or like charge. Okay, and we have seen that once they acquired similar charge, they were actually repelling each other. Okay, so this is the first conclusion that we can draw, that like charge repel each other. In fact, this statement is known as the fundamental law of electrostatics. Now, in the third part of the experiment, what you have to do is rub the glass rod with silk cloth and plastic rod with the fur. Then, to one pith ball, you will touch the glass rod. Okay, so maybe this is the pith ball that I am touching with glass rod. This is glass rod, and touch the plastic rod to the other pith ball, and you will find that these two pith balls get attracted towards each other. Okay, so from the first two steps we have concluded that like charge, they will repel each other, but in this case we are seeing that the two balls are getting attracted towards each other, which means that the charge that was transferred by glass rod to this pith ball and the charge that was transferred by plastic rod this speedball were different. Okay, and we can also conclude that unlike charges attract each other. Understood? So from the third step, we can conclude two conclusions. Okay, so we can come to two conclusions. One is that unlike charges, they attract each other. The second is there are two kinds of charges. Well, so here actually this line will continue. Like charge or like charges repel each other, and unlike charges attract each other. Attract each other. And second conclusion is that there are two kinds of charges. Okay, so these are the two conclusions that we can draw from this experiment. Now, actually, you know what? When glass rod is rubbed with silk cloth, or whenever any two materials are rubbed with each other, then one body acquires one kind of charge and the other body acquires the second kind. Okay, glass rod acquires one kind of charge and a silk cloth will acquire the other kind. And when these two materials, after they are charged, they will be brought closer to each other, you will see that they are getting attracted. And if you bring them in contact, they will lose the ability to attract objects, or they will lose the ability to attract each other, which means that the charges they acquired got neutralized. Okay, net charge in both the bodies have become zero once again. Now, see, this is a charged body, this is a charged body, and when you bring in contact, the net charge should actually get added up, but instead it is getting neutralized. So how can this happen? This is only possible if we add a positive number and a negative number of equal magnitude, right? If we have a positive number and a negative number of equal magnitude and we add them, then the sum comes to be 0, right? So that is why Benjamin Franklin, a American scientist, named the two types of charges as positive charge and negative charge. Okay, now this might be the reason why he named the two types of charges as positive charge and negative charge. Okay, because this is the charge that will be acquired by one body, and negative charge will be acquired by the other body, and when you will bring them in contact, they will get neutralized. Okay, so in order to comply with that experimental observation, the charges were named as positive charge and negative charge. According to his convention, the charge acquired by glass rod when rubbed with silk cloth is positive charge. Understood? That means when glass rod will be rubbed with silk cloth, the glass rod will acquire a positive charge, or the charge that will be acquired by glass rod is the positive charge. And when plastic rod is rubbed with fur, the charge that is acquired by the plastic rod is the negative charge. Understood? Means which one is positive and which one is negative. This is what he said. He told that the charge acquired by glass rod when rubbed with silk cloth is the positive charge, and the charge that is acquired by plastic rod when rubbed with fur is known as negative charge. Understood the two different types of charge from this activity? Okay. Now, a body that possesses an electric charge is called a charged body or the body is said to be electrified. A body that possesses an electric charge is called a charged body, or we say the body is electrified. Okay, and a body that does not possess an electric charge is called a neutral body. Now the question that actually comes in our mind is that why does a body acquire electric charge? Understood? When the two bodies are rubbed, or when that glass rod or the plastic rod was brought in contact with the pith balls, okay, the pith balls got charged. Now how they got charged or why they got charged, that is the question that comes in our mind. Why do bodies, or we can write how does a body becomes electrically charged? Matter is made up of atoms, and atom consists of a central nucleus with the protons and the with the protons and neutrons within it held together by strong nuclear force, and the electrons, they revolve around the central nucleus in an atom. Alright, now the electrons are negatively charged particles. The electrons are negatively charged particles. Okay. They have a magnitude of 1.6 into 10 to the power minus 19 coulomb. On the other hand, the protons are positively charged particles. Okay, this will be actually minus 1.6 because they are negatively charged particles, and protons are positively charged particles having a magnitude of plus 1.6 into 10 to the power minus 19 coulomb. Thus we can conclude that the electrons and protons, they have charges that are equal in magnitude. Okay, the only difference is the difference in their sign. One is positive and the other is negative charge. Means one has a positive charge and the other has a negative charge. The neutrons, on the other hand, neutral particles, means they don't have any charge in them. Do you know? Now actually the property called polarity differentiate between the two types of charges. Means, let me write actually what is polarity. I missed it out. Polarity is the property that differentiates the two types of charges. Understood? So we can say that electrons and protons have same magnitude of charge but of opposite polarity. Okay, that's why they will behave little differently, or they will behave in the opposite way. Now, under ordinary condition, an atom has equal number of protons and electrons. That's why it is electrically neutral. So if you want to make a body charged, then you have to somehow or other create a difference in the number of protons and neutrons. If you can create a difference, then the body will become charged, because it will have a net charge in the body. So now how can we create a difference in the number of electrons and protons? For that, see, the protons, they are held within the nucleus by strong electrostatic forces of attraction. Also, mass of proton is very much greater than the mass of electron. Mass of proton is very much greater than the mass of electron. So, it is not possible for the protons to be removed from the atom. Understood? But the electrons, and more precisely the valence electrons or the loosely bound electrons in the outermost shell of an atom, they can be easily removed by the application of suitable energy called work function of that electron. Means if you apply energy to the loosely bound electron in an atom, means electrons in the valence shell that experience the minimum attractive force of the nucleus, what will happen? If you apply them suitable energy, they can be easily knocked out and transferred to another body. Now, the body that has lost electrons has a difference in the number of protons and electrons, as well as the body that has gained electrons has a difference in the number of electrons and protons. One body has a deficiency of electron, one body has, and the other body has an excess of electron. Actually, I forgot to say another thing as well. The charge in an electron can be denoted by minus E, and the charge in a proton can be denoted by plus E. E represents the magnitude of charge, okay, and plus and minus denote their polarity. Okay. Now, which body will have a deficiency of electron? Obviously, it is the body from which the electrons have been transferred, and that body which has acquired the electrons will have an excess of electrons in it, and thus both the bodies become charged. Okay. So it is the actual transfer of electron which makes a body charged. The body which will have a deficiency of electron means there are now more number of protons, right? So will become positively charged. And the body which will have an excess of electron will become negatively charged, because here the number of electrons will become more than the number of protons. Understood how a body becomes electrically charged? Okay. Means electrons has to be transferred from one body to the other. Then there will be a difference created in the number of electrons and protons, and they will become, one body will become positively charged and the other body will become negatively charged. Okay, so I am actually rubbing this part. Now, electrons have a finite mass. We all know that mass of an electron is (9.1 into 10 to the power minus 31 kg, which is finite. So, whenever electrons are getting transferred from one body to the other, or whenever any body gets charged, okay, its mass also changes slightly. That body which loses electron or which has become positively charged due to the transfer of electrons, or in other words, which has a deficiency of electron, will have a less mass, or its mass will decrease slightly. So a mass of a positively charged body decreases, positively charged body slightly decreases. Because electrons are getting transferred from the body, and mass of a negatively charged body slightly increases, because electrons are getting added to this body which is negatively charged. Understood? Well, now we will look into the concept of conductors and insulators, and this will be the last topic for today. Conductors and insulators. Okay, what are conductors and what are insulators? I think in class 10 we have already studied. We will just once again recollect. Conductors. Conductors are materials that allow charges to flow through them easily. Okay. Now, since protons cannot move, protons are immobile, so that allow charges to flow through them means we are talking about the electrons, or more precisely the loosely bound electrons or the free electrons. Okay, so the conductors are the materials that allow electrons to flow through them. They have a large number of free electrons within their volume. Actually, it is due to the presence of a large number of free electrons that conductors allow electric charges to flow through them very easily. Free electrons means the outermost electrons, or the electrons in the valence shell of an atom, are very loosely bound to the nucleus, so they can move very freely, and the free electrons reside within the volume of the material. Means if this is the conductor, then you will find the free electrons within the volume only. If you give an excess charge to a conductor, the excess charge will reside in the surface. Suppose you have given a positive charge to this conductor. Okay, the positive charge will remain in the surface. Okay, similarly, if you give a negative charge to this conductor, then the charge will get distributed in the surface of the conductor. Okay, so excess charge in the surface of the conductor. Also, the charge density will be highest in the sharp points. For example, our hairs are very sharp. That's why during a thunderstorm, if you are outside, then there is a high possibility that the charge can flow to the ground through your body, because the hairs will serve as a good path for the charge to flow. Understood? That's why if you are outside, always cover your head or and kneel down, or you take shelter under any rooftop or any building. That's all about conductors, and insulators are just opposite of conductors. Insulators are materials that do not allow electric charges to flow through them. Okay, why they don't allow electric charges to flow through them is because they don't have any free electrons. Even the electrons in the outermost shell of an atom in an insulator are tightly bound to the nucleus. Okay, they are actually held tightly by the nucleus of the atom. That's why they don't have any free electrons and they do not allow the electric charges to flow through them. Okay, due to the absence of free electrons in them. And any excess charge given to a insulator will remain in that very place where you have given it. Suppose this is an insulator and you have given an excess charge in this region, say positive charge. Then the positive charge will remain here only. It will not get distributed, unlike conductors where the charge was getting distributed in the surface. Similarly, if this is an insulator and you have given it a negative charge in this region, the negative charge will remain there only. It will not move or distribute itself. This is the difference between a conductor and an insulator. Understood? So that's all for today. Hoping to see you very soon in another video. Till then, take care of yourself, study well for your exam, keep studying, and have a wonderful day ahead. Goodbye.